Okay, so your host, if you don't know who I am, there's a few people that don't. I'm Simon Whiteley. I'm a System Safety Engineering Consultant for my company, Whiteley Aerospace Safety Engineering and Management Limited. I'm an independent System Safety Engineering Consultant and Company Director. I've got 2 degrees, a Bachelor of Engineering in Aerospace Engineering and a Master of Science degree in Safety Critical Systems Engineering. And I've worked as a System Safety Engineer across all parts of the engineering and product lifecycle across a number of industries, including civil and defence aerospace, where I've done most of my work, air traffic control, weapon systems, armoured automotive, maritime, defence nuclear, rail, healthcare and government IT. I offer training, coaching, support and consulting utilising the stamp-based methods across the whole system lifecycle. So if you want a hand, give me a call and we'll sort something out. So who else is on here? Well, I'm pleased to say I've got over 60 people from 20 different countries across the entire globe, from over 17 different industries. So we've got people from Australia right around the world, through to China, through to America, through to Central Europe. So pretty much all over the place. And it's really great to see that interest from across the globe, and especially from all of these different industries, because ultimately this method can be applied to any industry, and it just so happens I've chosen the aerospace air traffic control on this occasion. So if you have a particular case study you'd like to see in the future, don't forget to put it in the box and let me know. Okay, so the agenda, finally we got to the agenda. So I'll talk a little bit about the event, I'll talk a little bit about the runway incursion definition, I'll then give a brief overview of the stamp-based process CAST, accident analysis, and then I'll talk about my results, focusing on the control structure, model and development, and then significant observations with following up with the Q&A at the end. So first off, what is a runway incursion? The ICAO document 4444, the Procedures for Air Navigation Services Air Traffic Management, they define a runway incursion as any occurrence at an aerodrome involving the incorrect presence of an aircraft, vehicle or person on the protected area of a surface designated for the landing and takeoff of an aircraft. Now, you'll notice that in this case, well, in this particular case study, and strictly both aircraft were correctly present on the protected area, i.e. it was intended that both of those aircraft be on the runway at the same time. So strictly speaking, you could probably say that the Tenerife disaster was not a runway incursion, but the semantics of whether it's a correct presence or incorrect presence isn't really relevant to safety, I don't think. And it's also important to point out that the language we use to describe and define a problem can actually influence and constrain our thinking about the problem and how we can solve it. So an example of that would be if we design the system so that we prevent the incorrect presence of an aircraft, then we won't have any runway incursions, we won't have any accidents. But if we don't prevent the correct presence with the context and circumstances such as in this accident, then we'll still have accidents associated with aircraft crashing into each other on the ground. So the Tenerife disaster, this occurred on the 27th of March 1977, and it was very recently the 40th anniversary of what's termed the deadliest accident in aviation history. Now this is often termed by various pundits and writers as being the aviation's equivalent to the RMS Titanic disaster of April 1912. So this is a quote from one of the surviving Pan American pilots, Patrick Smith, that was in a recent Telegraph article. And I think this is an important quote for 2 reasons. The first is, obviously it highlights the view of somebody involved in the accident, but also it highlights the implicit direct causality view of this particular accident, which is very pervasive. The magnitude of the accident speaks for itself, but what makes it particularly unforgettable is the startling set of ironies and coincidences that preceded it. Indeed, most airplane crashes result not from a single error or failure, but from a chain of improbable errors and failures, together with a stroke or 2 of really bad luck. Never was this illustrated more calamitously, almost to the point of absurdity, than on that Sunday afternoon 40 years ago. So I've highlighted the various terms there that refer to the likelihood of this kind of event was improbable. It was a number of ironies and coincidences, and it wasn't just a single error or failure. There was a lot of bad luck. Now, I've highlighted chain of improbable errors and failures because it's important to point out that this person clearly has an implicit accident causality model, which is the direct causality model, chains of failures, chains of events, slices of cheese. And it's all about errors and failures. And you'll notice as we discuss through this, and based on the stamp view of accidents, it's not just direct causality, it also includes indirect aspects of causality. And we'll talk a lot about that later on. So the runway incursion itself, so this occurred at Tenerife North Airport, as it's now called, which was Los Rodeos, as it was called in the 70s. And this was on the Canary Islands in Spain. And it occurred at 1706 local time, and the weather was particularly implicated in this particular accident. So there was a rapid variability in the weather. There was light rain and fog patches. The runway visibility was down to 300 meters in places. Essentially, from a layman's perspective, it was very foggy, intermittent fog, and it made operating on the airfield very, very difficult for all involved. So these are the two aircraft that were involved. On the left, we've got the KLM Boeing 747, which is the aircraft that attempted to take off. And then on the right is a Pan American Boeing 747, which was still on the runway when the KLM began to take off. Now, these are the sources of information that I've used. I can supply those links to you afterwards, but I've also attached some of the key information to the webinar itself. So if you have a look at your handouts, I don't know if, depending if you're working on Windows or iPad or something like that, there should be a button for the handouts, and you can download those and have a look at those at your own pace. So how I applied CAST, a brief overview of the process. So before we get into doing CAST accident analysis or doing any kind of CAST analysis, we need to do a bit of preparation. Now, obviously, this is a CAST accident analysis of a case study, an accident that's already occurred. And so what I've done here, the preparation is subtly different to what you would do in a real accident investigation. So the standard activities, I've collected some source information, I've reviewed it and extracted various details. And then as I've gone through the CAST accident analysis process, I've extracted further details just to be very clear about the specifics. Now, the information I've extracted is regarding the accident and unwanted outcomes itself. So what was the ultimate outcome? And then the associated hazards with that. And then information to help me develop the control structure, the HCS, and the timeline. And that covers things like system components and the interactions between those components, such as control actions, algorithms, process or mental models, actuators, sensors, system disturbances, and context. And an example of a system disturbance in this example is the fog banks. So before you get into CAST accident analysis process, you do three standard activities. The first is you define the accident or unwanted outcomes. You then identify the associated hazards, and then you define the high-level safety constraints which the hierarchical control structure is intended to enforce. And then you jump into the CAST accident analysis process. Now, that process has three main aspects. You've got the creation of the timeline, the system modeling, the creation of the control structure, and then the causal analysis of that control structure. Now, the timeline, the creation of the timeline, it's not a specific activity to CAST accident analysis. That's a standard activity that you would do as any existing accident analysis already. And once you've done that, the actual process itself is you define and record the control process or the physical process where harm could occur, where energy is transferred. And then you develop the timeline, the sequence of events, and then the hierarchical control structure. Now, personally, I prefer to develop the timeline sequence of events first because it really helps you to organise your thoughts and information and understanding to a standard frame of reference, the timeline. And also the information you collect to create that is also the same information that will go into the hierarchical control structure, without the time information, obviously. Now, it's important to recognise and consider that this is just a case study of an existing accident investigation. So I've used a small set of information sources, the original investigation report, etc. There's obviously no opportunity to look for further facts or investigate further apart from look at other sources of information. But if you go beyond the original investigation reports and the other investigations associated with that, you get into the realms of hearsay, which may not necessarily be factually accurate. Now, the hierarchical control structure model I've created, obviously it's not been validated because I'm a solo analyst. I don't have any subject matter expert support, and I don't know what I don't know. So there may be important information that's missing, and I may also have introduced some biases into this investigation. So if you spot something that you think is obviously missing that's important, please put it in the comments, let me know, and we can talk about it. So the analysis process then, so we now analyse the HCS model. So the first thing we do is for each of the components we've identified, we identify and examine the following 6 aspects. So we look at the safety constraints, the requirements, any safety related roles or responsibilities. We then look at the controller's feedback, the control and feedback ability of that individual controller. So what actuators and sensors does it have, and were there any failures or any issues or degradation with those? Then we look at the specific control actions of that controller, and then we look at the process or mental model, depending whether it's a human or some other kind of controller, and then we look at the interactions amongst the controllers, and then any contextual factors. And then we move on to look at the interactions, coordination and communication amongst those components and across hierarchical levels, because it may be that there's some important factors that are not due to direct influence. And also focusing on those that contributed to the outcome, including timing and sequencing aspects. As part of that, we also examine dynamics and changes in or to the control structure, including weakening. And we'll talk a lot about that later on when we talk about the weather, the conditions, the fog, and how that affected the control structure, but also the coordination amongst the air traffic controllers and the various aircraft on the airfield as well. And then as part of that, we'll highlight those aspects that were unsafe, inadequate, flawed, or not enforced, including failures. Now, I've highlighted there that obviously this analysis is not like other traditional methods in that it focuses not just on failures or management of failures, but also unsafe issues that are not necessarily failures. You know, the system behaved as designed, but because it was designed and implemented to be dangerous, that was what the outcome ultimately was. And then we record questions, observations, and recommendations. So that is essentially, in a nutshell, everything that you would do as a CAST accident analysis. Now, CAST's ultimate goal is to establish what was the control structure that existed to enforce those high-level safety constraints, and then how and why each level of that control structure allowed or contributed to the inadequate control at that level. And then we make recommendations and suggestions. So things like what changes to the control structure are necessary so that the high-level safety constraints can be enforced. But we've also got to be mindful there may be circumstances where the control structure that we uncover may not actually be able to enforce those safety constraints, and so is fundamentally flawed and either needs to be redesigned or potentially stopped operating. But we can talk about that in questions and answers. Okay, so results. Overview of the results. So first off, accidents, unwanted outcomes. So this is a dramatisation from a documentary on YouTube of the KLM aircraft just before it impacted the Pan American aircraft that was on the runway. So in the bottom right hand corner you can see here that the Pan Am aircraft was still taxiing up the runway towards the Charlie 4 taxiway exit. It was actually instructed by the air traffic controller to leave at the Charlie 3 exit, but as you can see, that Z shape or S shape turn is something very difficult for a 747 to do, especially in a thick fog. And so there are questions over whether the Pan American crew thought that the air traffic controller really meant leave by the Charlie 4 exit because it's too difficult to do the Charlie 3 turn. But that was never established in the accident investigation report. And then the KLM obviously took off from the far end and then impacted the Pan Am, slicing its roof off and causing devastation, as you can see from this picture. So the top picture is a picture of the Pan Am aircraft from the port side, showing the devastation. Everybody on board the KLM aircraft lost their lives. So the survivors came from this picture, this particular, this view. And then you can see in the bottom picture there the debris field and how the KLM aircraft came to rest approximately 300 or so meters from where it impacted the Pan American aircraft. So the specific outcomes then, what were the outcomes? Well, you might say, well, it's really obvious. We lost 2 Boeing 747 jumbo jets. We killed 583 people. 61 were injured and survived. There was damage to the airport facilities. There was major disruption to airport operations. And then I found in a Time magazine article from 1977 an insurance and legal claim estimate at the time of $2.25 billion. Now, bearing in mind that in 1977 that was a lot of money, but if you contrast that with 2017 dollars, that's about $9 billion today. Now, I haven't been able to validate that number, so it might be less, it might be a lot more. If you have any information or knowledge about that, I'd love to hear about it. So the official investigation essentially distilled it down to 3 basic causes. So the KLM aircraft took off without clearance, though there is suggestions that perhaps they believed they had clearance, and we'll talk about that later. There was a misunderstanding between the ATC and the KLM aircraft because of the use of usual terminology. So there was no failure in the terminology because they were using the usual terminology of the day. And then the Pan American aircraft was still present on the runway. It missed the exit that it was commanded to take. So what are the associated hazards with the accident, with the outcomes? Well, I've highlighted 2. And the first one I've entitled Hazard 01 Runway Incursion. And I've essentially taken the ICAO definition of a runway incursion and I've essentially chopped off any occurrence at an aerodrome involving the, and then I've specifically taken off incorrect presence. Because ultimately, whether people die and things get damaged or destroyed doesn't really care whether they were present correctly or incorrectly. So that's why I've chopped that off and shortened it to the hazard is the presence of an aircraft when an aircraft is landing or taking off. And then hazard 2 is conflicting trajectories that lead to a loss of safe separation margin between aircraft and vehicles. So that takes care of the moving aircraft components. So what are the high-level safety constraints? Well, essentially what high-level safety constraints are is a transposing of the hazards. So I've transposed hazard 1 into a constraint that the hierarchical control structure shall prevent the presence of an aircraft, vehicle or person on the protected area when an aircraft is landing or taking off. And then because of this particular accident where you had an aircraft still on the runway and you had another aircraft that was in a position ready to take off, I, from my background as an air cadet doing a lot of shooting on the ranges with the RAF, we were trained about this loaded gun situation. So you're essentially told never to point a weapon at anything you do not want destroyed, regardless of whether the safety catch is on or whether it's even loaded. And you might say from a stamp perspective that's a control algorithm that's trained into people who handle weapons, that you just don't point the weapon at anybody, regardless of whether it's loaded or the safety catch is on. And that behaviour essentially mitigates a number of people potentially accidentally getting shot or killed. So that's why I've added that extra safety constraint in there, so that the control structure controls whether an aircraft is in a position to take off or land, and then that has implications for how the system operates. And then the third one, so the high-level safety constraint 3, the HCS shall prevent trajectories that lead to a loss of safe separation margin between aircraft, vehicles or people. Okay, so we're going to jump into talk about the timeline now. So this is the creation of the timeline, the sequence of events. Now what I do is I use a standard, what's called a sequence diagram, which some of you might recognize from systems engineering. Now this is essentially the various people, controllers involved in the incident across the top, and then from the top down to the bottom is the timeline. Now I've specifically selected the last sort of 10 minutes of this accident because I'm focusing purely on the control structure between the two sets of pilots and crew and the air traffic controller. Now, if you're not really familiar with this, I am going to go through this very quickly because there's a lot to get through, and obviously I lost a bit of time at the beginning. So, the KLM first officer, he was in charge of the radio communications, whilst the KLM captain was in charge of moving the aircraft. So the KLM first officer contacted the air traffic controller to request permission to taxi, which was authorised, and they were authorised to backtrack down runway 12 for takeoff on runway 30. Then the Pan American first officer, who was also in charge of the radio, he requested permission to taxi, which was authorised, and they were instructed to leave at the third taxiway on the left, so Charlie 3 on this diagram. KLM first officer then told the air traffic controller they were passing taxiway Charlie 4, which was acknowledged, and it was at this point the air traffic controller gave the KLM aircraft permission to perform a 180-degree turn and then report ready for ATC clearance. And then slightly after this, the air traffic controller reminded the two aircraft that the runway centerline lights were unserviceable. Now it's important to recognise that these two aircraft, 300-ton aircraft full of people and fuel, are basically taxiing down a runway with almost zero visibility in places. So it's extremely difficult for them to see not only the runway centerline, but also the taxiway exits. The air traffic controller reminds the Pan American to leave at the third taxiway on the left, and then it's at this point, 17:05 and 36 seconds, that the KLM comes to a stop and is in a position for departure at the end of the runway. So essentially, using my loaded gun analogy, the gun is now loaded and it's pointed down the range. The KLM first officer tells the KLM captain, wait a minute, we don't have clearance. Now on the voice recorder there's some evidence that the KLM captain went to raise the throttles on the engine, and the KLM first officer essentially stopped the KLM captain, and then that's when the KLM captain said, no, I know that, go ahead, ask for the clearance. So the KLM first officer told the air traffic controller that they're now ready for takeoff and they're waiting for the ATC clearance. The air traffic controller provided them with their ATC clearance, which, if you're not familiar, an ATC clearance is literally an instruction to tell you what flight path you're going to take after you've left the ground. So it's like a route clearance. It's like telling you where to go on a map. It does not give you clearance to take off. That is a separate clearance. The KLM first officer acknowledges that clearance, and then it's at this point that the KLM captain said, we're going, check thrust, and began to start the takeoff effectively. And it's at this point that the KLM first officer reported back to the air traffic controller, we are now at takeoff or taking off. Now there is some question over what was actually said because it's not clear from the data recorders, and so depending on whether it's we are now at takeoff or we are taking off, there is some question over whether that was sufficient information for the air traffic controller to know that there was now a dangerous situation set in motion. The air traffic controller then responded with OK, and then there was a pause of about 2 seconds, and then the controller said, stand by for takeoff, I will call you. Now, incredibly unfortunately, the Pan Am aircraft heard the KLM response that they were taking off, or they'd interpreted it at that. And they'd heard the air traffic controller say okay. And it's at that point that they jumped on the radio and said that we're still taxiing down the runway. And unfortunately that crossed over, stepped on the air traffic controller's transmission. So ultimately on the flight deck of the KLM, there was a lot of static, or what's called the heterodyne effect, and the transmission was essentially garbled. Though it was still, you could still hear what was said, but it was very difficult to hear. Now, the KLM captain and first officer were obviously engaged in taking off in a critical phase of flight. And the air traffic controller responded back to the first officer of the Pan American aircraft to essentially say, report clear when you've left the runway, at which point the Pan American air crew said, yeah, okay, we'll report when clear. The controller said, thank you. Now it's at this point that the KLM flight engineer, the third person on the flight deck, questioned whether the Pan American was clear. The captain said, what did you say? And the first officer said, is he not clear, that Pan American? And the captain said, oh yes, emphatically. And then it's at this point, at 17:06, 40 seconds, that the Pan American captain sees the KLM landing lights at approximately 700 meters coming out of the fog. The KLM first officer called V1, which is a takeoff speed, and then the KLM captain began the rotation. The first officer commanded the captain to get the Pan American aircraft off the runway, so they gunned the throttles and started to turn off the runway, and then the collision occurred. Now there was a fire and two explosions. Other aircraft on the airfield and flying over the airfield reported seeing the explosions and fire. They reported that to the air traffic controller, and then it's at this point the air traffic controller issued the emergency response crash command. So that's in a nutshell what happened. Now you'll notice that this is a standard sort of part or feature of any accident investigation, but it's important to point out that it really is a superficial analysis of what happened, and it gives a partial indication as to some of the reasons why the event happened. Now, as we step into the CAST accident analysis, you'll see where the real value comes from, where the real detail comes from. So we create the hierarchical control structure model. Now, we do that by first defining the control process or the physical process that's related to the high-level safety constraints. So in this case, I've chosen the trajectory or path of the two aircraft. And then once we've defined that, we then ask, what was the control structure that existed to enforce those high-level safety constraints? So I like to think of this really simply as completing a jigsaw puzzle. So I know that I've got a jigsaw puzzle. I know it's got some boundaries. I know I've got to find some jigsaw pieces. I know that they fit together in some way, and there's a bit of a hierarchy. You know, there's a top of the puzzle and a bottom of the puzzle. So this is just a control loop, standard control loop. You might be familiar with it. And this is what I would refer to as one of the jigsaw pieces. So essentially what you're trying to do when you're building the control structure is you're trying to find these jigsaw pieces and then understand how they fit together, whether they have actuators and sensors, and how they interact with each other. And this is where the real, power of this method comes from. So thinking in terms of jigsaw pieces and control structures, it gives the analyst, the investigator, a natural path to follow, to think, and a structure to work to. And for me, this is what makes stamp-based assessments so powerful and so straightforward, because of the way it organizes your thinking and your understanding. And it also allows you to spot where holes are. So obviously if you're putting jigsaw pieces together, you can logically see where those gaps might be. And if you're doing an original investigation, you know you need to go and look in that area for evidence or information. So this is just a quick list of all the various jigsaw pieces that I identified from the various bits of information that I reviewed. So I've highlighted in bold the ones that I've extracted and put into the hierarchical control structure. So let's analyze the model. So this is a high-level view of a detailed control structure. So this particular one includes the various parties and information that are mentioned across the various sources of information. And I've included there some of the clear interactions that are clear from this information source. And where there is no clear detail about the interactions, I've included some arrows with some question marks. And so if we were doing an actual investigation of this particular occurrence, then those arrows with question marks may be sources for further investigation. So particularly in this case, if I was doing this investigation myself, I would be very, very interested to know more detail about the airport or ATC management and how they were, how air traffic control and air traffic controllers actually work together to work this very busy airport on this particular occasion. Now, I've also highlighted in here the emergency response management and the interactions between the rescue workers and the various aircraft, because on the day the fog was so bad that they couldn't see the flames or the fire from both aircraft. They could only see the KLM aircraft because that was closest to the fire station. And it was only when they deployed and began fighting the fire on the KLM aircraft that it became apparent that there was another fire further up the runway. Now, if they'd have known that there were two aircraft on fire sooner, there may well have been more survivors on the Pan American aircraft. Now, I'm not going to analyze this one in detail because there's loads there, so I've basically summarized it into this. Now, this basically captures a lot of information into a very simple diagram. So you've got the Pan American aircraft on the left, the KLM aircraft on the right, and they essentially control the trajectory of those aircraft. And they are under the control of the air traffic controller via some radio equipment or radio frequencies. And the arrows on the outside and across the middle, they essentially represent the visual feedback that would have been present on the day had the fog not disturbed it. So I've highlighted that with this diagram. So the external disturbance on this air traffic control system, if you like, was the fog bank. So the fog bank essentially degraded or destroyed those visual feedback loops. And so on the day at the time, we are primarily reliant upon the control structure provided by the radio equipment and the way voice communications works across radios. So I've expanded that a little bit more for the KLM aircraft so that I can address the captain, the first officer, the flight engineer and the aircraft, their interaction with the aircraft. And then because we haven't got much time, I'm only going to focus on these three controllers: the aircraft captain for the KLM, the Pan American aircraft and aircraft crew, and then the air traffic controller. So there's a lot here, and I'm conscious that we're getting quite close to time, so I'm going to go through this as relatively swiftly. So on the left, so safety constraints and requirements. So I've highlighted the three high-level safety constraints and then the one that was not enforced. So the KLM captain or the aircrew, they shall prevent trajectories that lead to a loss of safe separation margin between aircraft. So clearly that didn't happen on the day, so we need to understand why the control structure did not prevent that, did not enforce that control, safety constraint. Now I've also highlighted some other safety-related responsibilities, and that is that the captain shall operate, command and manoeuvre the aircraft in accordance with mission objectives, the flight plan, operating rules including aircraft operational envelope, including ground manoeuvring limits, and also weather visibility minimums. Regulations, e.g. the crew duty time regulations, first officer and flight engineer input, and then ATC instructions. Now the control and feedback ability, actuators and sensors. So obviously this person, this individual, is a human Mark I. Now there was no evidence presented that the controller's ability to enact control actions or receive feedback was compromised, failed, or in some form was inadequate. Now this individual is a native Dutch speaker, so English was a second language. They had accented communication, and that may have contributed to issues with interactions amongst the various parties in the control structure. And also there's a mention of what's called the filter effect by the ALPA report. So this is a circumstance where the pilot, the captain, the first officer did not hear the Pan American transmissions on top of the APCO transmissions because of the squeal, but also because of the workload. You know, they were conducting the takeoff and their call sign was not included in that radio communication, so they wouldn't be privy to it, they wouldn't be awaiting that communication. and then also the workload and arousal level. Control actions. So the captain was performing the checklists whilst the first officer was communicating with the air traffic controller. They manoeuvred the aircraft through a 180-degree turn in fog on a 45-metre wide runway. So bearing in mind the 747 is massive and a 45-metre runway is not that big for that kind of aircraft. So it was quite a challenge to do that. The KLM captain commanded the first officer to request the ATC and takeoff clearance. And one of the recommendations I made there is to consider the appropriateness of requesting effectively 2 clearances simultaneously. And then this is where the unsafe control actions begin. So the captain initiated the takeoff before the first officer had completed readback of the ATC route clearance. So one of the recommendations is that takeoff shall not commence until the instruction readback and acceptance by the ATCO has occurred. Another unsafe control action is the captain initiated takeoff without takeoff clearance. So this is where one of the official recommendations, and there was only 3, the official recommendations is for exact compliance with instructions. And then another unsafe control action, the captain dismissed the the flight engineer's question regarding whether PA 1736 was clear of the runway, and there may be some valid reasons for that. You know, this is a relatively high stress safety related operation that they're conducting, and if the flight engineer asks what appears to be a nonsensical question, then why would the captain want to engage in that discussion? And then another potentially unsafe control actions, and I'd like your view on this. The captain attempted to pull up and fly over the Pan Am aircraft. Now, in this case, the aircraft basically scraped its tail down the runway and managed just to get off the ground and impacted the Pan Am aircraft. Now, if the circumstances have been different, could that behaviour of trying to pull the aircraft off the ground be considered an unsafe control action? That's just a question for you to have a think about. The process, the mental model. So what's the mental model of the KLM captain? Well, there's a presumption that the ATC instructions are usually safe. The KLM aircraft was cleared to taxi to the holding position of runway 12 and change frequency from surface to approach frequencies. So they were asked to change frequencies. Now that's interesting because that suggests that the control structure may have changed. If the 2 aircraft, if the Pan Am aircraft and the KLM aircraft were on 2 different frequencies, that could have still resulted in the same accident. The only difference is the KLM aircraft or the flight engineer may not have heard the Pan American aircraft transmission, and likewise the Pan American aircraft may not have heard what the KLM aircraft was doing. So there needs to be some further investigation about that potentially. Now, the mental model of the KLM captain presumably is that the runway is clear and that the Pan American aircraft had vacated the runway. Else, why would they take off if they knew there was an aircraft still on the runway? So there are questions about that. The weather visibility was rapidly changing and close to takeoff visibility minimums, and so there may have been extra pressure there to go when there's a break in the clouds. The ATCO issued an ATC route clearance and takeoff clearance together. The ATCO acknowledged that KLM 4805 was taken off with OK. So from the KLM captain's perspective, they'd received a clearance, the runway was clear, and the ATCO had acknowledged that they were taking off. So everything's fine. The KLM flight engineer interrupted a critical phase of flight with an apparently nonsensical question about the runway being clear, and the captain may not have heard the ATCO or the Pan American transmission due to the squeal interference or due to focus on a critical phase of flight, not expected to respond to messages not containing their call sign. And then the interactions. So I'm going to talk specifically about the blue interaction. So the ATCO and the Pan American simultaneous transmission caused a radio squeal interference on the flight deck, but it was not that clear. It was not unintelligible, but it was unclear. So one of the recommendations I've made is that safety critical and time critical commands amongst controllers shall not be corrupted, blocked, or otherwise prevented. So contextual factors. So we've already highlighted that there's challenges with communication due to multi-language culture accents. And then also the Netherlands government introduced a crew duty time regulation which removed the captain's discretion to extend crew duty time and imposed absolute rigidity. So one of my recommendations is, we need to think about the emergent properties and associated implications due to the imposing of rigid rules, because obviously that can, that's a high level requirement control action down through the control structure, which when it gets to the front line can have unintended, potentially dangerous implications. Now the KLM captain was a senior pilot at the airline and an instructor for over 10 years, and there's perhaps susceptibility to behaving as though he was on a training simulator sortie, where he would typically behave as a pseudo air traffic controller for the purpose of training. Now one of my recommendations is to consider the potential for people to behave and have multiple roles or control algorithms and applying inappropriate control algorithms at inappropriate times. And the KLM first officer was inexperienced. So there's a recommendation there to recognise that there's potential increase on workload and emphasis on the KLM captain performing the various tasks, cross-checking and such like. So he is essentially the leading person. The first officer is not necessarily able to challenge or support the captain more effectively because of his experience level. Now it's important to point out, and it's pointed out in the Dutch Safety Board report, that most of the contextual factors are considered normal pressures, i.e. a normal part of being a pilot operating under those conditions. So this person was a normal person behaving under normal operating conditions, but unfortunately it resulted in an accident. So let's talk about the air traffic controller. Now I'm going to go through this relatively quickly because time is now short. On the left-hand side, I've highlighted that all three of the high-level safety constraints that we spoke about earlier, they were not enforced by the air traffic control officers. And also, there's an implied safety constraint or requirement that the ATC shall use unambiguous instructions, and that was clearly not enforced. The control actions. So the air traffic controller instructed the KLM to perform a 180 turn at the end of the runway and report ready for ATC clearance. Now, on its own, that seems like a perfectly normal thing to do. But in the context of the safety constraint I mentioned earlier about the control structure preventing an aircraft to be in a position to take off or land, then this is an unsafe control action in that context. There is another, that is the KLM 4805 ATC route clearance was provided with a delay and included the words takeoff. So this is where some of the other official recommendations were. Avoid the use of takeoff in the ATC clearance, and then also the enforcement of a time separation between the ATC clearance and the takeoff clearance. Another unsafe control action is that there was an acknowledgement of the KLM transmission with a 2-second, with a 2-second pause, and then followed up with stand by for takeoff, I will call you, which is the second part of the message, which was stood on by the Pan American transmission. Now the process mental model situation. So the air traffic controller has no indication that the KLM was not stationary. So that's some missing feedback from a control structure perspective. Now, one of the recommendations that was discussed, and I've discussed with other people, is the introduction of ground radar. So obviously at this airport there was no ground radar facility. But in this particular circumstance, the fact that the ATCO knew that the KLM was not stationary, it may be that it might have led to the ATCO knowing a collision was going to take place, but not being able to do anything about it because of issues with the potential radio communications. Or it may be that they were able to, say stop to the KLM, but the KLM had so much energy it wasn't able to stop in time and take off, and it would have meant more lives were lost. So there's those interactions there to think about. Now the air traffic controller was not expecting the KLM to take off, and he perhaps interpreted the KLM first officer comment that they were at takeoff or were taking off as that the KLM was at the takeoff position. Now it's important to recognise that there's some inconsistencies between the various accident reports that I've read and witness testimonies that contrast those facts. The ATCO could not know that a squeal made his message unreadable. And then also the ATCO's knowledge of the 747 geometry and ground movement capabilities and how fog might affect the manoeuvring, make manoeuvring more difficult. There was no, the ATCO may not have known that. So when they were issuing the clearance to the Pan Am to leave via the third exit and take the big S-turn, if they'd have known the geometry of the aircraft and that it was affected by fog, they may not have made that instruction. So the airport layout plan, or the actual airfield itself, it didn't have any designated taxiway exit numbers. So there was no detail on the layout plan of which exit was Charlie 3 or Charlie 4, and there was no actual signs on the airfield. And even if there were, it was very, very foggy, so they may not have been effective anyway. Now there's no detailed information, and this is really, really important. There's no detailed information in the various accident reports that talk about whether there was any miscommunication or miscoordination amongst the various air traffic controllers in the tower. Now it's not, depending on which source of information you look at, there was either one air traffic controller, 2, 3 or even 4. It's not actually clear in any of the sources of information, and that is important. I've already said there was no ground radar facilities. I've already spoken about the airfield and the airfield map layout. There was questions over whether the ATCO was distracted and whether there was any other environmental disturbances. So one of the recommendations I made was that the operational environment inside the tower should be recorded like it is on the flight deck of the aircraft. Now there was some mention about a football match, some controversy there, and that wasn't investigated by the Spanish investigators, not investigated by the Spanish investigation or covered very much detail by the various other investigators. It's important to point out that, like the crew, the ATCOs had been on duty all day, and they were dealing with a very significant traffic far beyond normal conditions, an aircraft that they'd never dealt with before, such as the 747s. I mean, this was a small airport at the time, so having massive jumbos there was very unusual. Standard procedures and terminology. So this is important. So for the guys and girls that are from the various air traffic control and aerospace industries, you might find this bit interesting. So at the time, there were some standard procedures and terminology in the ICAO Doc 4444. At the time, it was called the PANS RAG. Today, it's called the PANS ATM. But there isn't anything associated with not for requesting or providing ATC and takeoff clearances. So one of my recommendations, which could be done today, is to investigate the ICAO Doc 4444 and ensure that standard procedures and terminology are included with regard to requesting and providing ATC and takeoff clearances. So going back to the ATCO coordination radio frequencies, so you're familiar with this control structure. So if there was 2 radio frequencies in use at once, this is how it changes the control structure. So aircraft 1 is on one frequency, aircraft 2 is on the other frequency. And there will be no way for those aircraft to know or hear what's going on in that part of the control structure. Now if you extend that and think, well, there's 2 air traffic controllers, how do we make sure that those air traffic controllers coordinate appropriately with the aircraft to ensure that those dangerous trajectories don't occur? So let's talk about the Pan American crew quite quickly. So in the context of the Pan American air crew, there are 2 unenforced high-level safety constraints to do with the position and presence of an aircraft on the protected area, and then unsafe control actions. So they requested ATCO permission to taxi. So you might say, well, then taxiing onto the runway is directly in contravention to those high-level safety constraints, and so by definition that's an unsafe control action. They requested ATCO clarification of taxi clearance 3 times. So I've made a recommendation to clarify apparent confusion in communications. Was it the language of the investigation report or actual confusion? So in the Spanish investigation report, obviously it was a Spanish conducted investigation in the Spanish language. The report was originally in Spanish and then it was translated into English. So I'm using an English translation of the original report, which suggests that there was some confusion with the communication between the Pan American crew and the air traffic controller. Now, it's not clear whether there was genuine confusion or whether it's just the translation of the original information. And that raises questions about what language an investigation should be conducted within and how it should be reported to make sure that anybody else using that as a source of information for learning and improvements can get the most value out of it. So a significant unsafe control action is the Pan American crew taxied past the third exit of the runway, and this is where one of the official recommendations comes in, and that is exact compliance with instructions. Now, this raises questions about if you receive a potentially ambiguous clearance or instruction, if you think it could be potentially hazardous, you know, in the case of trying to do a really serious S-turn in a 200-ton plane on a 45-meter runway in fog, you would expect them to perhaps say something about that and say, are you sure you want us to do this? But there is practice amongst crews where language is potentially an issue, where they don't want to push it, they don't want to complicate things more, because it might, you know, it takes longer because obviously you're talking on the radio, but it might lead to more confusion and the increased risk of something bad happening. So you can understand why there's tension either way. Another unsafe control action, Pan American did not contact the ATCO when they suspected they had passed or missed the turn-in for the third exit. If they'd have done that, perhaps the KLM crew may have heard that. An unsafe control actions is the Pan American crew did not contact ATCO and state they were heading for the fourth exit. Now, this question here over the urgent transmission that they issued to say they were still taxiing down the runway, and the fact that this stepped on the ATCO broadcast. Now, is that an unsafe control action or not? You'd probably say it's not, but because there were safety-related connotations to those communications, the fact that it wasn't received or the fact that the ATCO's message wasn't received is potentially unsafe. And then finally, the Pan American crew attempted to avoid the path of KLM 4805 by turning and accelerating off the runway. So there's questions there, you know, contextually, that was the right thing to do, but without that context, is that really an unsafe control action or not? You know, there's a question there. So the process, the mental model. So they had uncertainty regarding the clearance provided by the ATCO, given that the third exit would have forced the Pan American to make some very difficult manoeuvres. We've spoken about that. And then finally, it was not possible for the Pan American crew to know what their transmission had potentially not been received by the ATCO or KLM 4805. So when they transmitted, they presumed that that transmission had been received and didn't expect the KLM aircraft to take off or continue their takeoff run. Now, the interactions. Now, we've already talked about the airfield layout plan or the actual airfield itself not having designated taxiway exit numbers. We've spoken about the simultaneous transmissions. We've spoken about the challenges with communication. Okay, so visibility conditions presumably prevented the Pan American crew from seeing the taxiway exits, especially because they're positioned high above the surface of the runway in the cockpit. It's about 10 meters, it's quite far. Okay, so we're nearly at the end, everybody. Key findings. So the interactions between and behaviour of the air traffic control officers or the Pan American air crew were not adequately investigated as part of the official Spanish investigation. The report does not include any detail or investigation of the ATCO or the Pan American crew, and if it had been recent, obviously further investigation would have been recommended. Now, my view is that the HCS was clearly inadequate. The HCS was not resilient to a straightforward human communication and understanding issue, such that the HCS was unable to prevent or even recover the situation. Now, I've also highlighted that the HCS, from a radio communications perspective, hasn't fundamentally changed in 40 years. Now, I acknowledge that there's new technology, you know, things like ground radar and lighting stop bar lights, but fundamentally the control structure I showed you hasn't changed. It's the same today. So consequently, the HCS, the control structure, needs to be redesigned, otherwise reoccurrence of this particular accident is pretty much inevitable. And obviously I recommend STPA for doing that. So it presents us with some unanswered questions. So Why did the air traffic controller permit 2 aircraft on the runway coincidentally? Well, everybody can say, well, it was a busy day, they wanted to expedite getting everybody off the ground, and that was the best way to do it. These were normal people doing normal things, trying to get the job done, and unfortunately it resulted in this catastrophic outcome. There are questions over why the Pan American crew did not leave the runway at the 3rd exit, but as I've said, the geometry, the fact that the weather was so bad, there was no turning signs or anything like that, they couldn't know where they were, and also how many ATCO were present in the tower and which were performing what service and on what radio frequencies, so ground control, runway control, or approach control, or a combination of both. Now, I did mention earlier on, the ALPA report mentioned that there was 2 air traffic controllers using 3 radio frequencies, so that control structure I showed you a moment ago with the split in the control structure, that was probably prevalent on the day. Now, there was another post-accident report that I've seen, which was provided by another European air crew. And they were on the Pan and left the airfield before the accident occurred. And they reported that there were aircraft taking off ahead of them, apparently without clearance, or at least not clearance from the runway controller on the runway control frequency. And it transpires that there were actually 3 air traffic controllers working on 3 different frequencies, giving both taxi, takeoff and ATC clearances, not strictly on the correct frequencies. And then also the questions about whether the air traffic controller was distracted, either by a football match or some other disturbance. So final thoughts then. So radio communications, mental models and loaded weapons. Radio communications are okay for normal conditions, but when things start to go sideways, the critical nature of the messages, the timing and whether they're received and understood becomes very serious. And radio communications is not that robust for that kind of important, safety critical, time critical communication. And then mental models. So you saw that there was 3 different groups. There was the air traffic controller, the Pan American crew and the KLM crew. And they had a variance in their mental models about the system, about the situation. The ATCO and the Pan American crew were not expecting the KLM to take off because they hadn't got clearance and the weather was close to minimums. Whereas the KLM crew, they believed that they had clearance to take off, and so they behaved as you would expect them to behave. And then also loaded weapons. So is it really appropriate to put aircraft in a position that all it takes is one mistake or one issue for a serious accident that kills potentially 600 people? Is it really appropriate? Now it's important to point out this event occurred on what was a relatively normal day in Tenerife from a weather perspective, but it was mixed up with a few abnormal conditions. Strictly no failures occurred, and we can debate that. I'm not convinced that there were any failures. This was normal people on a normal day behaving as best as they could with the circumstances they were in, but the system, the structure, essentially set them up to have an accident. So it forces a question, is today's control structure really adequate for normal and abnormal conditions? And what specific changes to the HCS are necessary to enforce those high-level safety constraints under all those conditions, including urgent and emergency conditions? So we already said, even if the controller knew that the KLM was moving, could they have actually done anything to prevent it? Or could their intervention have actually made it even worse? Because in this circumstance, at least some people survived, whereas if there'd been an intervention, perhaps nobody would have survived. So is the use of radio communications for real-time safety critical commands really acceptable? And what about implications for attempting recovery from a runway incursion? I've just spoken about that. So final thoughts, near misses. So an accident or near miss or incident reveals that the HCS is inadequate, fact. So if you have a near miss, you know by inference that the HCS is in some way inadequate in enforcing those safety constraints. So you know now that you need to go and look at it and have a think about it using this method. So it provides a massive learning opportunity. And near misses and incidents are really cheap learning opportunities because hopefully you've not killed anybody or caused a lot of expensive damage or disruption. And of course, this is predicated on using stamp-based methods, because this systematic approach, considering the control structure, looking at both dangerous successes as well as failures, it gives you a wider view of the system that you're dealing with. So finally, just a few questions for you then. So what near misses have you had that were worrying or that you've been exposed to? What keeps you awake at night? And would the power that CAS provides help? How could this support proactive safety management and particularly consideration of leading indicators? So that's the end of the case study. I know that's gone on a little bit because we had a bit of a technical glitch at the beginning, but now this is your opportunity to ask me loads of really horrible, difficult questions, and hopefully I can answer them. So actually as well, I'm going to try something slightly different with the technology today. So if you would like to come on camera, if you've got a camera or mic to ask your question, then let me know and I'll see what I can sort out, because it'd be great to hear your voice instead of me just talking all the time. So please put your questions in the box. If you've got a slide that you're referring to, put the slide number in there and then we'll answer your questions, hopefully. So please let me see what you'd like to know. Or has everybody gone to sleep? Oh, here we go. Somebody's talking. I'll email as there are more modern examples. Yes, thanks, Darren. I really appreciate that. Cheers. In fact, actually, I'll quickly go back to where is it? This slide with the various control structures. So this is just to highlight the coordination amongst controllers. So I did mention that there were a number of potentially 3 or more air traffic controllers talking on different frequencies. So just by having those extra controllers on different frequencies, that's complicated the control structure to such an extent that time-critical coordination, is potentially lost. So the idea is to have a robust control structure to enforce those safety constraints, and anything that doesn't enforce those safety constraints, you need to do something about it. You need to redesign the control structure. So if there's no questions or comments, then I'm quite happy to end the webinar there. If you want to talk about it or you want to ask any other questions or provide any comments, please send me an email. I've got a YouTube channel now. You're welcome to go and join that, subscribe, leave me some comments, like and share and all of the YouTube stuff. And if you want to be on any future webinars, obviously you're already on the list now, so I'll let you know. But if you've got any friends or colleagues who also want to be on future webinars, please go to the web address systemsafetywebinar.com and let me know, register, and we'll let you know when the next webinar occurs. I will be, just so you're aware, I'm going to be putting a couple of YouTube videos together, short, quick videos during the next week, talking about 2 recent incidents, and I'll let you know when they're available. But if there's no other questions, okay, there's a question about bow ties. So as explained, I'm interested. So Colin, thanks for the question. I'm interested to know why you feel this method is so much quicker than bow ties. Right, okay, so my personal view of bow ties is 2 points. The first is they're based upon the direct causality model. So this event leads to this event, leads to this event. And it's predicated upon identifying and dealing with failures. So if you put a barrier in place or some slice of cheese to prevent that progression, then in theory you should be safe. Now, that causality model is very straightforward, but it misses out some important aspects, such as the coordination. Now, let's have a look. Which presentation is this? So, come on, computer. So this, right. So when I get the right one on screen. So this control structure takes literally 2 minutes to put together. In fact, it takes longer to actually draw it than conceptualize it. Now, you can't describe a system using a bow tie that includes all the detail you see on this one picture. Because with a bow tie, because you're thinking about linear direct causality, you're thinking about events that lead to this, that lead to that, lead to the other. So in this particular accident, you might say one of the first initiating events is that the air traffic controller gave an ambiguous clearance to the KLM aircraft. Then you might say the next step is that the KLM aircraft acted on an ambiguous clearance, and then the final part is that there was an accident, a collision, everybody died. Now, that progression does not, that model does not include all of the various aspects that we've spoken about, such as, the loss of the visual feedback. Because obviously if the air traffic controller could see in broad daylight that the KLM aircraft had started rolling, then he might have acted differently. But even before that point, if the KLM aircraft had got the visual feedback, they would have seen that the airfield was not clear. Their mental model would be that there's an aircraft still on the runway, we're not going to take off. So there are so many different, if you draw a timeline, there are so many different branches of the way reality could have played out that the model would be just so complicated that you wouldn't potentially finish it. You just lose the will to live almost. Whereas with this model, the control structure, it provides you with a clear picture of what the entities and relationships are, and then you can start to look at the different scenarios. So in this case, we've lost the visual feedback. Another scenario might be that the interactions between the KLM aircraft and the air traffic controller and the Pan American aircraft was lost because of the dual transmission. But you wouldn't necessarily consider dual transmission as part of the bow tie analysis. I mean, I can talk a lot about bow tie. This is more about stamp on this presentation. But if you want to talk about that a bit more, we can do another time. Would you rather use texting over radio than voice over radio? So thanks, Simon. Thanks for the question. Would you rather use texting over radio than voice over radio? Well, ultimately the control structure that you can see here would be exactly the same. The only difference would be in terms of the timing and updates to the mental models of the various controllers. So if the air traffic controller sent a text message that contained, so if you sent a text message that in this case contained both the takeoff and ATC clearance, then strictly speaking, the KLM aircraft would see the message and have both clearances and then take off. Now, if the air traffic controller was forced to use a text message format, so the formatting of that text message and the content, what it shall and shall not contain, suddenly becomes really, really critical. And so that would need to be considered. So yes, if those things were designed that way and the control structure was put together that way, then yes, using text messaging may well have prevented this accident. But ultimately, you can't send a stop, stop, stop text message to then recover if the aircraft has decided to start the takeoff, there would be no opportunity to stop it. But that's a feature of the control structure. Okay, so Darren. So Darren says use of controller pilot data link communications already exists. CPDLC, yeah, that's right. Yeah, so there is a form of text-based communication called controller pilot data link communications, but I'm not sure, I don't know enough detail about it to say whether they would use it to issue these kinds of safety critical communications. I would imagine and probably recommend that they give the ATC clearance by text message, but any real-time communications such as the takeoff clearance or the stop, stop, stop signal is by the radio communications. But that would be a different control structure. This control structure would have an extra loop in it between the two aircraft and the air traffic controller. Okay, so is there any other questions before we call that the evening? I must apologise about the technical glitch earlier on, but we learn from these things. You know, it's a near miss. I've learned from it. I'll stop it from happening again, hopefully. Okay. So if there's no more questions, I will let you enjoy the rest of your day. I really appreciate your time. I'll edit the video and I'll upload it to the internet, and I'll let you know when that's available as soon as possible. All the very best, and I'll see you on the next webinar. Bye-bye.